Now I'll be showing the solutions of AIPMT 2015. The code for the booklet is F. Now I'll be discussing question number 136 to 140. The question number 136 is कि n number of electrons move in a circular motion. N number of electrons move in a circular motion. So we have to find the magnetic field produced by this motion of this electron at the center. Okay, let's call this center O. First assume a random cross section in the motion of the circular motion, and it's given in the radius of this circular motion is r. Okay. Since the frequency of this circular motion of the electron is n, that means it passes through a cross section n times in 1 second, right? So total charge passing through this cross section will be equal to, in 1 second, will be equal to n times e, and time taken is obviously 1 second. This implies that the current produced through this cross section will be equal to Ne upon 1. This implies that the magnetic field for a circular coil, it's similar to a circular coil whose radius is r and the current passing through the coil is I. And we know the magnetic field produced by a circular coil is nothing but mu naught I upon 2r. Just put the value of I from the earlier equation, you'll get this as mu naught into Ne upon 2r. Okay, so as we see, the option E resembles this equation. So option 3 is correct. This was question number 136. The next question is question number 137. For question number 137, we have a diagram, a PV diagram, and initial and final states are given. As in, for point A and point B, both pressure and volume is given. For point A, the pressure is given to be 5. Okay, the unit of pressure is kilopascals and the unit of volume is meter cube. The pressure at A is 5 kilopascals, at B it's 2 kilopascals, and volume at A is 4 meter cube and volume at B is 6 meter cube. Okay. Knowing the pressure and volume parameters of this process from A to B, we can find, the question asks, the gas is a diatomic gas. Okay. So for a diatomic gas, the question asks about the change in internal energy. So as we know from the laws of thermodynamics, change in internal energy is nothing but NCV delta T, where delta T is the change in temperature. So we can write from this equation NCV delta T is nothing but T2 minus T1, and T2 and T1 can be determined from the values of P and V. From the equation, ideal gas equation, as we know T is nothing but PV upon R NR. Just put these values NCV into T2 minus T1, and T2 we can write as P2V2 upon NR minus P1V1 upon NR. Okay. Now N gets cancelled. You'll get CV as, okay, for a diatomic gas, CV is 5 by 2r, because the degrees of freedom in a diatomic gas is 5, and we know CV is nothing but Fr by 2. So just put the values 5r by 2 here, you'll get P2V2 minus P1V1 upon R. Now again R gets cancelled, you are left with 2.5 times P2V2 minus P1V1. Just put the values of P2V2 and P1V1. For 2 is the final state, that is state B. For that, P is 2 kilopascals and V is 6 meter cubes. So this will come out to be 2.5 times 6 into 2 into 10 raised to 3. Because it's in kilopascals, we have to convert it into pascals. So the conversion factor should be 10 raised to 3. Okay. Minus 4 into 5 into 10 raised to 3. Solving this, you'll get a result this result comes out to be, I think, minus 20 kilojoules. Okay, minus 20 kilojoules. So the option 1 seems to be correct. The next question is question number 138. For question number 138, there are two separate waves which are interfering or superpositioning at a given point. That means first equation is given as A sin omega t. Second equation is given as B cos omega t. So we have to find the resultant of the wave which is formed by the interference of these two waves. So we know from the principle of superposition, y effective is nothing but y1 plus y2. So we can write it as A sin omega t plus B cos omega t. Okay. As we know, a linear combination of two sinusoidal waves is also a simple harmonic motion. So this is a linear combination of two sinusoidal waves. So this will also form a simple harmonic motion, and it has an amplitude of root over a square plus b square. From trigonometric simplifications, we can arrive to this value. Amplitude comes out to be root over a square. Whenever two sinusoidal waves are interfered in such a manner, then the amplitude comes out to be root over a square plus b square. So the option 2 seems to be correct because it says it's a simple harmonic motion with an amplitude of root over a square plus b square. Okay. For question number 139, okay, we have an expression that relates velocity with displacements. The relation is velocity as a function of x is equal to beta times x raised to minus 12. Okay. Now we have to find the acceleration as a function of x. So for that, we know a particle's acceleration can be written as dv by dt or it can be written as v dv by dx. Both the expressions relate the velocity with acceleration, right? So for this equation's sake, we'll use acceleration as a function for this function. We'll use acceleration equal to v dv by dx. Okay? So first we'll differentiate this equation to get dv by dx. So this comes out to be beta times minus 12 into x raised to minus 12 minus 1. From the property of a differentiation like y is equal to x raised to n is nothing but y, its differentiation will be dy by dx is equal to n x raised to n minus 1. From the same property, we get this differentiation. dv by dx is equal to beta times minus 2n into x raised to minus 2n minus 1. Right? Now, acceleration. For acceleration, we'll just multiply velocity with dv by dx. We'll take this dv by dx from here and velocity from here and put these values here. You'll get beta square times minus 2n into x raised to minus 4n minus 1. Okay, so the option 1 seems to be correct. For question number, this was question number 139. For the next question, question number 140. Okay, for question number 140, there are two different molecules, nucleuses. One is aluminium 27 and other is Te125. The radius of this is assumed to be RAL and radius of this, let's call it RTE. So we have to find RTE in terms of RAL. Okay, for that we know the relation radius of a nucleus is nothing but a raised to 1 by 3. Okay, so just using the properties of ratio, you'll get a RAL upon RT should be equal to AAL upon AT raised to 1 by 3. Now put the values of mass number of aluminium and mass number of Te as 27 and 125. You'll get 27 upon 125 raised to 1 by 3. That is nothing but 3 by 5. Okay. Now, as we know the value of RAL, we can say RTE is nothing but 5 by 3 times RAL. So, option 1 is the same as this. Okay, this was question number 140. Thank you guys for listening to the solutions.